Hi, we are looking at section 4.2a, homework, problem number 7. So in this problem, we're asked to use the left and right endpoints and the given number of rectangles to find two approximations of the area of the region between the graph of the function and the x-axis over the given interval. And then they ask us to round our answer. So I would just say, if you don't have a calculator handy, I would make sure you have a calculator handy, because this does involve a little bit of arithmetic and it's just kind of convenient to have your calculator handy. So I'm going to sketch out a rough graph of what this is really asking us to find, and it's going to be a very rough graph. You can definitely reference a more exact graph. So we have our x and our y axis, and then I have the point 1. And I'm going to really exaggerate this in 3. And of course, that's not to scale. That's okay. It's a sketch. So I get some grace with that. So we have here 0, 3. And then for x equaling 1, our corresponding g value, we would have 6. I'm just going to put that kind of right here. And then when x equals 3, our corresponding g value, we're going to have 30. So that's going to go quite a bit larger. And again, this is just a rough sketch. So probably the not so greatest parabola you've ever seen, right? That's okay. Just use your imagination, pretend that's a parabola, because it's a sketch. And if you really, like I said, want to be consistent, you can graph it using a graphing utility or something like that. That's okay. So what we want to do is we want to approximate the area under this g of x function, this y equals g of x function, using 8 rectangles. So there's 2 ways that we do this. One of them is we can use the left endpoints. Okay. And actually, let's go ahead and break this up. This is 2. Then we have 4 rectangles. We should have 8. 1, 2, 3, 4, 5, 6, 7, 8. And again, it's a rough sketch. So it's just kind of to show you what we're doing. It's not meant to be very accurate. In fact, when you work these problems, you don't necessarily have to have this visual. So, okay, so we have each of these rectangles, and they're a light blue color. Apologize if you're colorblind, because I do use kind of some color references, but this is, so we have these rectangles under the curve. So I see that if I use the left endpoint values, I get kind of an approximation for an area under the curve. Okay. So this is an approximation. If I took the area of these 8 rectangles, I would have approximately the area under the rectangle. You can see that there's some open spots, and that's okay. We're not looking to be exact. We're just looking to approximate. And we'll talk about later how to get that exact. But right now, we just want an approximate value. So I'm going to find the area of these 8 rectangles. And rectangles have a really nice area formula. Okay, it's just the height or the length times the width. Now, ideally, this would be perfectly drawn to scale and the width would be equal. Okay, so the space in between them would be equal. We're going to call that delta x. And so the space between each of these rectangles is going to be the length of the line. And then we have 8 rectangles. If we put an even width in between them, we would have 3 minus 1 divided by 8. So 3 minus 1 is the length of the line. And then we want to divide it up into 8 segments. So we get 2/8. And then we go ahead, and then the width of each one of these is going to be 1/4. And that makes sense, right? Because we have we're going from just the number 1 to the number 3. So it shouldn't be super large widths on our rectangles. And then the height of each of these rectangles, when we start off with this, I can find the height by looking at, I actually use these G values. So I can find the height by looking at each of the different G values. So if I were to add up the area of this first rectangle, it would be 1/4 times this G. And we start off with G of 1. Okay. So we have that, and then we'd have plus G of, and this next X value comes at 1 plus 1/4. So I'm going to have 5/4 times that width, which is 1/4. The third rectangle, we're going to have G, and we will have 6/4, and of course you can reduce that if you want, times 1/4, plus, we've got 3 rectangles so far, plus G times 7/4 times 1/4. And, you can hopefully see this pattern. And notice that each of them, we're adding together something that has a 1/4 coefficient. So a lot of times you're going to see that when you look at an explanation for the solution to these, they just factor out that 1/4 right away, and that's okay. So when we look at the approximate area, notice we're using the left endpoints. Could even put the word approximate here. But we're going to have this 1/4 factor, so I'm going to take that out. And then I'm just going to add up each of these corresponding G values. So I'm factoring out and continuing that pattern until I get to this G or X value, which is 1/4 less than 3. Okay, so we have 1/4 G of 1, G of 5/4 plus G of 6/4. Again, I'm just doing that to continue the pattern. Don't feel like you have to write that every time. I'm going to erase this just to give myself some extra space because I'm going to run into that space. Plus G of 7/4 plus G of 8/4. Of course, that puts us at 2. We wanted to. G of 2 plus G of 9/4 plus G of 10/4, and then plus G of 11/4. Get that space out of there. And end our parentheses. Let's double check that we have 8 rectangles. 1, 2, 3, 4, 5, 6, 7, 8. All right, so that involves, like I said, some arithmetic. So if you have a way to quickly find each of these G values, that'll save you some time. But otherwise, it's just going to be some plug and chug at this point. So we'll kind of just take a second, and I don't mean a literal second, but we're going to go ahead and evaluate each of these. So we have 6 plus . Of course, my calculator keeps everything in fractions, so I don't have to do that arithmetic. Feel free to approximate it though if you want to. I don't blame you. Of course, you can see there's a lot of room for human error in this too. And that's just the way that this kind of goes down with all this arithmetic. I think there's not a lot of calculus, but there is a lot of opportunity for just little errors. All right. Then we want to add up all of those values. And at some point, I'm going to have to just tell my calculator that we're going to switch to approximations because these decimals are going to get probably pretty large. If you're using Desmos or Excel or something like that, just for convenience for this problem, I don't blame you. Just make sure that on a test you could, if called to it, which you very likely might be called to do it on a test, you could work it out using a traditional calculator. That just might involve more arithmetic, more time. But I think all of this we can do. So 465 fourths. Again, you may have already switched to using approximations, and for that I wouldn't blame you. And just to save some space, I'm going to start actually kind of writing some of these on the right hand side. So I know that's not good practice, but the slide is limited in space. So we have 1/4 times the 465 fourths. All right, so I'm going to multiply those. And of course, that gives us 465 16ths, and then I'm going to approximate that. And so when we do that, we get approximately 29, and it says to round to 4 decimal places, which is exactly 625. Okay, so let's go ahead and then do the right-hand side. So the right endpoint's the area above the curve. So with that, I'm going to use, I have this rectangle. Again, we still already have it split up. Our width is going to be the same for each of these, but we're going to start off with the right endpoints. So I have then this rectangle, and then I have this one, and I have this one. And so what you should notice, even with my errors and things like that, you should notice that these green rectangles using the right endpoints, I'm definitely having some overage. And then so I'm going to be above the area under the curve. Let me see if I can switch my color here. I'll stick with it. So we would call this like our upper bound, and we would expect it to be greater. And then the actual would lie somewhere in the middle, okay? Because the first one we did, of course, it wasn't as large as we wanted it. So we have this 1/4. Now, the good news is we're using almost the same G values. It's just the last one, we're not going to go all the way to that right. We don't have that right rectangle. So if I start over here, this first height is going to be G of 3 plus, again, we're going to have that G of 11/4 plus G of 10/4 plus G of 9/4 plus G of 2 plus G of 7/4 plus G of 6/4 plus G of 5/4. And then we've got our 8 there. And you don't have to redo all that arithmetic. You have all of it here. The only difference is, you'll have that G of 3 and you won't have that 6. So I'm just going to go ahead and add these together. I'm going to take this sum that I had, this 465/4. I'm going to subtract 6 and I'm going to add G of 3, which we found earlier to be 30. So I'll take that 465/4. And again, you can rework all of it out. I'm not showing all the steps. I'm kind of shortcutting, using some of my previous work. So I'll subtract this 6 because that's not a height of rectangle that we have. And then I'm going to go ahead and add that G of 3, which is 30. Okay, and so when I do that, all of those G values, I get 561/4. And of course, we can take that and multiply that. And I'm counting on, that I didn't make an error somewhere, which again, there's so much room for error with a lot of these. And so even this, I worry I'll come back later and look at this video and see that I had some glaring error, or a student will send me an email. So always check the notes too, because there's room for error. Okay, and so we've got this upper bound, we've got this lower bound, so we can put those in our boxes. And then just for me, yeah, that's it. So definitely fill those in, and you've got, and the good news is your lower bound is definitely smaller than your upper bound, so that's a good check. So thank you.